Welcome back. Let's start by understanding about external tables. There are two ways of creating external tables in serverless SQL pool. The first one is using the create external table command. This command creates an external table on the data that's already present in the storage, for example, Azure Data Storage Gen 2. This is simply going to put a structure to the data in folders and files and not move that data anywhere at all. In simple terms, the effect of the external table creation is just metadata changes. No data in the files or folders will be affected by this process. The second way of creating an external table is using the create external table as select RCDA statement. This command lets us select data from the storage using a select statement and copy that data to another location in the storage, and also makes a table available on top of that data so that it could be queried similar to the create external table command. This creates the metadata to define the table data source and the file format, and also it copies the data that's being selected. One important note I want to reiterate here is that serverless SQL doesn't have any storage option available within it, and the data always resides externally, for example, in Azure Data Lake Storage Gen 2. In order to create an external table, we need to have a couple of other database objects in place. As we know, we create external tables on the Data Lake Storage or the Blob Storage. The first object we need is the external data source. This defines URI of the storage account and the folder part. It can also have the credentials required to access that data. The next one we need to have is the external file format. This object has the information about the format of the files, such as file type, for example, whether it's a delimited file or a Parquet file, etc., and also it holds the information about the delimiter and encoding. Using these two database objects, we can create the external table which holds the reference to the data source as well as the file format. It also contains the column names, data types, information about what to do about rejections when there are failures. The uses and the applications can now access the external table without worrying about any of the underlying details. The main takeaway here is that creation of the external table also involves creating the external data source and the external file format. Creation of the external data source. Let's specify the following parameters. We can specify the location of the storage, i.e. we can specify the URI of the Blob Storage or the Azure Data Lake Storage Gen 2. This helps us avoid specifying the long URI every time you want to access the data. We can specify the credentials that gives access to the storage account and the container being accessed. This is an optional parameter. We do not need to specify this if we are accessing data from a public URI which we have anonymous access. Also, we don't need to specify this if we already have access to the storage location via Active Directory pass-through authentication. For example, we already have access to the storage account that we created for this course. So we do not need to specify this, and we can ignore the credential parameter. In a later session, I'll show you how to access under the storage to which we don't already have access. The third parameter is the data source type. By specifying the value as Hadoop, we can use the Java technology, but that is only supported in dedicated SQL pool. So we should leave this as blank for the serverless SQL pool so that it uses the native technology. Once created, the external data source could be used in the creation of the external table. And we don't have to specify these. Find the details again. Also, one of the other advantages of having the external data source is that it lets us provide access to the storage via our database credentials without explicitly providing each user access to this storage account. Here's the SQL command template for creating the external data source. You need to provide a unique data source name within the database. As I said, it takes 3 arguments: location, credential, and type. Let's see an example. Here, we've given a name of the data source as NYC, and it's called taxi data. We specified the location which points to the container NYC taxi data in our storage account. I've given a credential here, but as I said, it's not required for this storage account as we already have access to this storage account that the Active Directory passed through authentication. And finally, I didn't specify the type as we are going to use the native type, and that's the only support that type for serverless SQL. If we are in dedicated SQL, we could use the Hadoop type as well. External file format lets us specify the following options. We can specify the format type at the time of recording. The supported format types are delimited Parquet and Delta amongst these delimited and are in general availability where Delta is currently in public preview. So please don't use Delta for production workloads as of now, but please keep an eye on the updates from Microsoft and you can start to use Delta once. That's in general availability as well. Data compression can take the values of compression format applied to the files. Delimited text could be on Z, SIP, codec, and Parquet, and Delta could be of gzip or snappy compression. And the third parameter format options is one layer available for delimited files. This helps us define the field terminator encoding, possible actions, etc. Amongst these three parameters, one large format type is mandatory and the other two are optional parameters. Once you create the external file format, you can use that in the creation of the external table and do not have to worry about specifying all these finer details again. Here is a SQL command template for creating the external data source. You need to provide a unique file format name within the database. As we said, it takes the three arguments format type, data compression, and the format options. Let's specify things like field terminator, encoding, parser version, etc. for the delimited text as shown here. Here is an example of external file format for the delimited text file. As you can see here, we opted to automate the data compression as the file in our case is not compressed. Creation of the external table requires us to specify the following: the name of the data source that provides the location and the access to the location. The location of the file and the file name within the date to source the name of the external file format object which contains the format types, data compression, etc. List of column names and data types. Apart from these, there are a couple of optional parameters. Firstly, you can inform the SQL pool whether you want to allow inconsistent via read options. Also, you can define your reject options. This lets you specify the number of rejections allowed before casting a failure and where to write the rejected records, etc. Please note that at the time of recording this option is only available for CSV, Parquet. Here's the SQL command template for creating the external table. You need to provide a unique name for the table. You can specify the documentation to specify the database and the schema names. Database names can be limited. If your current database is the one you create in the table in, you specify the schema name. If you want to create the table in a specific schema rather than DB or otherwise, you just need to specify the table name. As we said, it takes the arguments such as column details, location, data, source, file format, read options, and reject options. Reject options. Let's add specified things like type rejection value and the location where the rejected record should be returned to, etc. as shown here. Here is an example of the create external table command. As you can see, I've chosen to write the rejected records to a separate location. Also, I asked query to fail if the file had more than 10 rejected records. Now that we understand how to create an external table, let's create our first one in the next session.